Welcome to Math 110, College Algebra at Northeastern College. In this lecture video, we're going to review the beginning algebra materials. I want y'all to kind of get used to how I do algebra in this course. Alright, so I always start up reviewing algebra talking about the concept of terms. Okay, understanding terms is very important because term dictates how we look at algebra. Term dictates how we solve equations, simplifying expressions. So a term by definition is a number, a variable, a product of some numbers, and a quotient of some numbers. So for example, any number that you see, like a 4, a -7, an 8, okay, is considered as a term. Every number is considered as a term. A variable, a single letter variable, x alone, y alone, z alone, or t alone, is considered as one term. The definition gets a little bit tricky here. What's considered a term is a product of some numbers. Product in algebra referring to multiplication. So what it's saying here is a multiplication of some numbers is considered as one term. For example, the 2 times 3 I wrote right here. 2 times 3 we know is equal to 6. 6 is a number, 6 got to be a term. The 6 come from 2 times 3. So because of a multiplication of anything, the 2 times 3 is actually one term. Even though you're looking at the two numbers here, 2 and the 3, because that multiplication sign, it actually makes it one term. So multiplication between anything is referring to as one term. So the 2 and the 3 here is called the factors. Okay, these two factors together makes up one term. So 2x means 2 times x. So 2x will be one term. 3y, things like x times y or xy is considered as one term. Quotient means division. So we are saying here a division of some numbers is only considered as one term. Using this one here in the middle. For example, the 2x over 1 minus x. So this rational expression is actually one term. Okay, this is actually one term because this is a division between something. Now, if we look at the numerators alone, if we just look at the numerator alone, the 2 times x on top is actually one term. Okay, so what separates between term is the addition and subtraction signs. Outside the parentheses is what we use to separate between terms. So the denominator here has a 1 minus x. So the subtraction sign here actually separate my denominator into two terms. I have a 1 and a negative x. But again, this expression itself at the beginning is only one term. If we look into the expression, the numerator is 1, the denominator is 2 terms. Alright. Now, you might be wondering, why does this matter? Think about in terms of if I need to graph, okay, this expression in a graphing calculator. How do I type it in? Well, if I want to type it in, the 2x is actually one term, so I can simply type in 2 times x divided by the denominator 1 minus x. If I type in it this way, I'm actually telling the calculator to do a 2x divided by 1 then minus x. So the calculator sees it as 2x divided by 1 then subtracting x. So that means the calculator sees this problem as 2 terms rather than 1. Alright. And that's the reason why when I type in the 1 minus x in the calculator, I actually need them to be in the parenthesis. Because in that case, calculator see the denominator as one term. Okay. So let's go back here. 2x divided by 1 minus x. Close parenthesis. Now, typing it this way is a little bit dangerous because my numerator has a variable in it. So calculator can see this a little bit funny. So what will be a safer way is put the 2x in the parenthesis divided by, put the denominator in the parenthesis as well. Now in this case, calculator will actually look at this thing correctly. So the calculator right now sees it as a one term divided by one term. And we will talk about the rational expressions in the next review video. And you will understand why I will put the 2x in the parenthesis. Alright, so real quick, what is very strange is when I simply write down a 1 minus x, that's two terms. But when I write, versus if I write 1 minus x in the parenthesis, that actually becomes one term. Because what's up front of the parenthesis is a positive 1 times. So that actually makes it one term. Multiplication between anything is one term. So that's the reason why my note here says we are using the addition and subtraction signs that are outside the parentheses to separate between our terms. Okay. Alright. So let's look at some example. Identify terms. So to figure out how many terms is in a problem, the first thing you do is look for addition and subtraction signs outside the parenthesis. So for my expression here, I got subtraction sign here, plus sign right here. So two of those signs will give me 3 terms. What's in front of my subtraction sign is one term. Okay, between the subtract and the plus sign is one term. The subtraction sign go with the 3y, so my second term is a negative 3y. And my last term is positive 4. Alright, so this expression has 3 terms. Alright, identify terms. Looking for addition and subtraction signs that are outside the parentheses. So right now what's outside the parentheses between 2 and the parentheses is a multiplication. So multiplication between anything will actually makes it one term. Alright, so the problem itself is one term. Now, if you look at what's inside the parentheses, so terms inside the parentheses, because there's a subtraction sign inside the parentheses, there's only one subtraction sign in the parentheses, so that will separate between the two terms. So I actually have 2 terms in the parentheses, but the problem itself from the beginning, okay, is actually only one term. So term dictates how we go about simplifying or solving these expressions or equations. Now, don't get confused with this problem compared to 2 times parenthesis of 4x. Because the difference between this problem is inside the parenthesis here there's no plus or minus signs, so that means inside the parenthesis is one term, versus here I got 2 terms. Okay. Alright, let's look at this rational expression. Subtraction sign outside the parenthesis here will make it 2 terms. So my first term, x minus 4 over x. My second term, negative 4. Alright. Now if you look at my first term, my numerator has 2 terms. So when we put this in the graphing calculator, we have to put the x minus 4 in the parenthesis. So the calculator will view this as a one term over one term. I will put that x alone in the parenthesis because variables, okay, one term variable in the denominator or numerator by itself, when they're not in the parenthesis, calculator may look at them funny. Okay. Now, because this expression has two terms, I will actually put this whole first term in a parenthesis, because that will tell the calculator that it's actually a one term. Then subtract 4. Alright, so here my graphing calculator here, I will start out with the parenthesis, which is my blue one, and I will open another parenthesis for my numerator, x minus 4. Close my numerator, so that my numerator is one term right now, divided by, I will, just to be on the safe side, I will put my variable x alone in the denominator, put that parenthesis around it. Then I'm going to close my blue parenthesis. So all that, calculator view them as one term. Then you subtract 4 on the very outside the parentheses. And we can graph it later on. Okay? Alright, so we will talk more about this. Okay? Everything we do dictate by terms. So we will talk about terms a lot. Alright, the way I solve linear equation one variable is slightly different. I write it out slightly different. Okay, and I will show you this in a minute. But normally, we have 6 different steps that we follow for solving linear equations. Figure out how many terms you got. Do some distribution or multiplication if needed. Combine like terms on each side of the equal sign. And then, we're going to move all the variable terms to one side of equal sign and move everybody else to the other side. We just, when we're moving terms across the equal sign, we change the sign to the opposite one. So step number 4 is where I write it out slightly differently. Okay, I just want you all to see the way how I write it out. Then we combine like term, and the last thing we do, divided by the coefficient. So this example is not very great, so I'm going to change one number here, the negative 3u, I'm going to change it to a 4 right here. I'm going to change it to a 4 right here. Alright, so by looking at this equation, the left side of it, subtraction sign outside the parenthesis, is 2 terms. My whole right hand side, there is no plus or minus sign outside the parenthesis. So my right side is only 1 term. So I see my third term has a parenthesis, so that reminds me to do a distribution. So I will distribute my 4 onto the negative 4u and the negative 6. So first term, nothing to do. Negative 12u still the same. Second term, negative 24 equal. Alright, 4 times negative 4u, negative 16u. 4 times negative 6, negative 24. Alright. Tell you what, I'm going to change this 6 to a 7. How about that? Alright. I'm going to change this 6 to a 7, excuse me. So that will give me negative 28. Alright, so combine like term on each side. So the left side, these two are not like term. The right side, these two are not like terms, so there's nothing to combine. So let's move them. When I move terms back and forth, I move the variable terms first, and the side that I move my variable term, it depends on which one is bigger, which variable term is bigger. So here, negative 12u is bigger than that negative 16u. So I will move my variable term to the bigger side to keep my variable term positive. Alright, so if all the u is going to be on the left side, that means this negative 24 got to be moved back to the right hand side. So the left side, negative 12u is still there. When the negative 16u move over to the left side, it becomes positive 16u. The right side, negative 28, still there. When the negative 24 move over to the right hand side, it will become positive. Okay, so I move my variable term to the left side in this problem because this variable term on the left is bigger. So I always move it to the bigger side. Okay, I don't always move to the left. I move it to the bigger side. All right, negative 12u plus 16u will give me positive 4u. The right side will give me negative 24. So I'm trying to keep my variable term positive at all times. So the last step, divide both sides by coefficient 4. My answer, u equals negative 1. Alright, let's try another one. And again, throughout the video, you can pause it at any moment, okay, if you need to catch up. Alright, let's look at this. I see how many terms I have. Equal sign in the middle, left side, there is 1 plus sign outside the parenthesis. The right hand side, there's 1 plus sign. So the left side here, 1 plus sign, separate two terms. My first term, positive 7. My second term, positive 4 times all that is 1 term. Because like I said earlier, multiplication between anything is 1 term by itself. Okay, so by me highlighting like this, you can see that 7 got nothing to do with that 4 plus 4. 7 does not plus the 4, because the positive 4 here is in a separate term. Alright, my next term in front of the plus sign is 1 term, and behind it positive 9 is 1 term. Alright, step number 2, do our distribution. 7, first term, nothing to do, still 7. My second term has a multiplication here, has a parenthesis in multiplication, so we will distribute. Positive 4 times 3n, positive 12n. Then we say positive 4 times negative 2, negative 8. Okay, that's the way how we say it. Equal in the middle. My third term was in front of my parenthesis is a positive 1. If it's nothing written there, it's a positive 1. Then we'll do a distribution. So that will give me negative 4n and a positive 5 still. My last term, positive 9 still, positive 9. Okay. So that's step number 2, distribute. Step number 3, combine your like terms on each side of the equal sign. What that does is shrinking this equation down a little bit. So my 12n still 12n. 7 can combine with negative 8, so 7 minus 8, negative 1 equals negative 4n. Got no one to combine on the right hand side, so still negative 4n. Positive 5 plus 9, positive 14. Alright, so before I move my term, I'm gonna find the variable term and see who is bigger. So in this case, 12n here is bigger than the negative 4n, so I will move my negative 4n to the left side, to the bigger side. So that means my negative 1 that was on the left side got to bring it to the right. Okay, so what I'd like students to do is be able to move terms and combine in their head. So this negative 4n come over will become positive 4n, plus the 12n will make it 16n. Set it equal to negative 1 bring it over will be positive 1. 14 plus 1 will be 15. So my answer, divide both sides by the coefficient 16. 15 over 16. So I'm not one of those instructors who will ask you to show me every step. I will be the one asking you to show me the necessary steps. If there are steps you can do in your head, do it in your head. Okay, I actually highly recommend that. Okay, if you want to write everything out, that will be fine. But throughout the semester, if there are steps I can eliminate, I will eliminate them. Okay, in these videos that you're watching. Okay. All right, let's solve this problem. This is solving for a specific variable. Okay, we're not. So this is a little bit different problem. There's no like term to combine here. All right, there's no parentheses, so there's no distribution. I see the left hand side, the equal sign, there's a subtraction, so that make it 2 terms here on the left. Phi z is a 1 term on the right. So if I want to solve for y, that means my variable term got to be negative 3y. So the 4x and phi z were just other terms. Okay, it's not my variable term. I'm just moving them away. Now, since my variable term here is a negative, what I can do is move it to the right, because that will instantly make it a positive 3y on the right hand side. So if the y gonna go to the right, that means the phi z got to go to the left side. So 4x is still 4x. Positive phi z come over to the left side, becomes negative phi z. Alright, so right now my y is not by itself yet, because it's my coefficient right here. So I would divide every term by my coefficient 3. So that means my y will equal to 4 over 3x minus 5 over 3z. Okay, and you can see, you probably notice that I don't always start from the left. I always start from from where the variable term is at. If the variable term was on the left side, I will begin writing on the left side. If the variable term was on the right hand side, I begin to write on the right hand side. So I always begin from where the variable term, or where the variable is. Okay, doesn't matter which side I'm on. I always read and write from the variable side. Okay, do not get stuck with always having variables on the left side. Okay, that's not a good way to learn algebra. All right, let's review distribution, multiplication, and multiplying polynomials here for a minute. So I did previous 2 example, I kind of already do some distribution for you. Okay, so I'm going to add another problem here right beside it. Big difference between a negative 2 times x plus 4 versus a 4x. And the biggest difference is, even though both problems are 1 term each, the one on the left, there's a plus sign in the parentheses, so that make it 2 terms, so that will be called a distribution. So that means the negative 2 will times x, negative 2x, and then you say negative 2 times positive 4, that will give you a negative 8. Since the 2 term is not like term, they cannot be combined. So this is it for my expression. The one on the right hand side, because this is only 1 term in there, so this problem is simply negative 2 times a 4x, which will make it just negative 8x. Okay, so how many terms a problem has, okay, dictates how we go about simplifying it. And that's why we got to understand terms first. Alright, problem look like this, probably look familiar. This is your 2 term times 2 term problem. So what you think about is your FOIL methods. I'm going to put it right here. FOIL methods. As you can recall, the F stands for first, the O stands for outer, the I stand for inner. Let me just do it right here. And the L stand for last. Oh, that didn't work out very good. Sorry. And the L stand for last. Oops, sorry about that. Sorry. Alright, so it turns out FOIL methods, I'm going to show you how this wording comes from, okay, by doing another problem right below it here. Okay, So technically speaking, FOIL method is basically a distribution with two different terms on the same thing. So what I mean by that is like this. Imagine looking at this problem, the x plus 6. Imagine the plus 6 is not there. If you only see this, naturally, you will say x do a distribution onto the x and the positive 3. So you will say x will times the x plus 3. Alright, now let's reverse it. Pretend the x is not there. Alright, so that means the positive 6 here will do a distribution onto the x and the positive 3. So these two terms is multiplying the same thing on the back. And that is actually what FOIL method means. Alright, so the very first thing you do is x times x. That's the reason why inside the FOIL method, x times x first, which will give me x squared. Alright, then we will say x times positive 3. So when you say x times positive 3, that would be your outer, which is positive 3x. Alright, so that's it for the first term for the x doing the distribution. Now, the positive 6 doing a distribution. So positive 6 times that same x, that will be called the inners in the FOIL methods, which is positive 6x. And the last thing you do will be positive 6 times positive 3, which will give you positive 18. Alright. So once you multiply them, now we combine like terms. The two middle terms here are like terms, so they can be combined. So I get x squared plus 9x plus 18. Alright. So this middle term, 9x, comes from the 3x plus the 6x. And the 3x is your outer. The 6x is your inner. So that means the 9x comes from the inner and the outer combined. So it turns out FOIL method is a shortcut. It's designed for students, or is designed to be done by looking at it. So the way you actually do this problem, the actual way it needs to be done is actually looking at this and write down the answer. Because the first thing you do in the FOIL method is x times x, which will give you x squared. The last thing that you do is the positive 6 times a positive 3, which will give you positive 18. So this middle term will be the inner and the outer combined. So the outer is x times positive 3, which will give me positive 3x. You do that in your head. The inner is positive 6 times x. So the outer is 3x, inner is positive 6x. When you combine them, then you get positive 9x. Okay, so this is the way I will actually do FOIL method in this class. I do not write everything out. I just look at it and just kind of I will walk you through it. Inner and outer combined give me my 9x. All right, now a little bit bigger problem like this one, you will have to write it out. This is a 2-term times a 3-term, so we need to work this one out. This is not a shortcut problem. So just like FOIL method is basically a distribution of x times these 3 terms in the back, then negative 4 times those 3 terms. All right, so x times x squared, positive 4x, positive 16. That will give me x to the 3rd plus 4x squared and plus 16x. Alright, that's it for x doing distribution. Now, negative 4 will do a distribution onto the x squared positive 4x, and positive 16. So negative 4 times x squared, negative 4x squared. Negative 4 times positive 4x, negative 16x. Negative 4 times positive 16, negative 64, I believe. Alright, so combine like terms. X to the third is your highest exponent, that is your leading term. Got nobody combined with. Alright. So the next one we combine is the next highest exponent. 4x squared minus 4x squared actually cancels out. X to the first power, 16x minus 16x cancels out. And so the only thing left with is negative 64. There you go. Alright. So I understand that there are many different ways to multiplying polynomials. There are a lot of different techniques. Okay. I sing, the little squared technique. Regardless what technique you learned before, I like y'all to be able to do this in a quicker fashion. Okay, because our problems in this course are big. Okay, this is only a tiny little piece of a big problem. So the more work you do, okay, the easier you will get lost track of what you're trying to accomplish. All right. Now I want to take a look at some what we so-called the special products. In beginning algebra, these are purely memorization type of problems. The first one called difference of squares. The way you recognize difference of square is the first thing you see is this is a 2-term times 2-term problem, just like a FOIL method basically. But if you look closely inside the parentheses, what you will notice is the first term are the same, the second terms are the same. The difference between the two parentheses is 1 plus and 1 minus. In that case, your outer and your inner will always cancel out. So that will only leave you with a times a is a squared, b times b is b squared. So when you recognize difference squared, you can simply write down the answer, a squared minus b squared. So for my example here, alright, 2-term times 2-term. Your first term are the same, second term are the same. One is positive, one is negative. Okay, so this is a classic difference of square problem. So x is your a, 2 is your b. So your a squared, that would just be your x got to be squared, minus your b squared, 2 squared, that would just be a 4. So my answer would just be a squared minus 4 without doing any work. Alright, let's try another one. Difference of squares. Alright, 9x, 9x, 6y, 6y, 1 positive, 1 negative. This is called a difference of square. So when you square your a, you square the 9x, that will give you 81x squared. Because the x also got to be squared. Minus. Always got to be minus here because the word difference of squares. Or if the two terms has a different sign, this is also called difference of square. Alright, your b right here squared, that will give you 36y squared. Okay, so you got to memorize the formula so you can recognize it when you see it. A lot of students get mixed up with difference of square with perfect square binomial or perfect square trinomial. Some textbook call it perfect square trinomial. Excuse me, I'm gonna put it up a little bit. I'm gonna bring these guys up. Alright, again, this is a shortcut. It's designed for you to see it and just write down the answer. Okay, so let me kind of explain this real quick. The a plus b whole thing squared. The exponent squared telling you your base, a plus b, is multiply itself 2 times. So basically, this is a 2-term times 2 terms. Just like a FOIL method, basically. Now, the difference between a perfect square binomial versus difference of square is the signs. First term are the same, second term are the same, but both signs in the parentheses are exactly the same. So that means the inner and the outer will not be canceled out. So think about this. If I do an outer, that's A times B, which is AB. If I do an inner, B times A, that's another positive AB. So how many AB do I have? 2 of them. And that's what this number 2 right here represents. You got 2 of the same middle terms. Okay. So I like students to do this problem just by looking at it. All right. X is your A. 8 is your B. So your answer will have 3 terms. A lot of students just simply say the answer is x squared plus 81. This is super wrong. Okay, this is not a different square type of problem. Okay, do not do this. You got to memorize the formula. So a squared, that means your x got to be squared, plus 2ab, take a number 2 times your x times your 8, that will give you 16x, plus your b got to be squared, which is 64, and that's your answer. It's a trinomial answer. Okay, the difference between the plus version versus the minus version is this sign right here is the difference. Okay, the last sign is always got to be positive. So rather than perform a FOIL method, I always recommend students to learn the shortcuts. It will be a tremendous help. It cut down a lot of work for you. All right, 4x minus 2 times 4x minus 2. So these two problems got the same first term, same second term. The signs are the same. So this is basically the same thing as 4x minus 2 whole thing squared. Okay. Alright, so we can just say your a got to be squared, which is 16x squared, minus, because this next sign is minus in the minus version, take a number 2 times your 4x times your 2. So 2 times 4 is 8. 8 times 2 is 16x. My last term, squared, will be positive 4. So that will be your answer. Alright, so I recommend students to learn this. I'm not forcing you to learn it. I'm just want you to see that this will be the way I will do these problems when we see them again. If you like to do a FOIL methods, okay, you can do that. You can write everything out if you like. Okay, just make sure that you understand that what I'm showing you right now is what I will be showing you later on the semester. Okay, as we get into this course. All right, the next thing I want to review in the beginning algebra is factoring. Factoring is a big deal in this class. I'm going to start you off factoring out the greatest common factor. So factoring is always about factoring polynomials. So here I got 2 terms. Okay, the greatest common factor between the 2 terms. Negative 15 and negative 15 are the same, so I can factor out a negative 15. Since both terms are negative, naturally I will factor out a negative 15. And what will be left, factoring is a division, so basically you are saying negative 15 going to negative 15, positive 1 time. So that will just leave you with a positive y. Negative 15 going to negative 15, positive 1 time. The only thing left is the x to the 3rd. So think of it like you're taking this negative 15 to the outside, so there's no 15 left for that x to the 3rd. And that's your answer right here. Okay, factoring greatest common factor is basically the opposite of distribution, which is a type of division problem. Alright, let's try another one. Factoring out the greatest common factor. And the way I'm doing this is always number first, and I'm thinking about the variable. Between negative 5, negative 10, negative 10, I can factor out a negative 5. Alright, and the way we look at the variable is make sure your variable you're going to factor out is actually repeated between all your terms. Alright, since x repeated between all three terms, we're going to pick the smallest exponent. Smallest exponent is 1, so I will factor out negative 5x. The y did not repeat in all three terms, so I cannot factor out a y. So times parenthesis. If I factor out negative 5x from the first term, that should be positive y squared left. Negative 5x on the negative 10, positive 2 times. If I factor out 1x from 3 of them, if I take away 1x from 3 of them, x squared will be left. Negative 5 on the negative 10, positive 2 times. Take the only x to the outside, no x left for that positive 2. And that's your answer. Alright, the next one, factoring by grouping. Factoring by grouping is a very particular type of factoring problem, because what you're going to see is always going to have 4 unlike terms. Okay, 4 unlike terms. There's no like terms here you can combine. So the way we do factoring by grouping is group them first, then factor. So I'm going to group the first 2 and the last 2. And the way I group them is underline them. From the first 2 terms, I'm going to try to factor out the greatest common factor. Between 20 and 55, I believe I can factor out a 5. Between s to the third and x squared, I'm going to choose the smallest exponent, x squared. So if I factor out 5s squared, that should leave me with 4s plus 11. Okay. Now, the last 2 terms, okay, what I want is the parentheses to match between the 2 sets. So for the second set here to have the same thing in the parentheses, it will force me to factor out a negative 1 between the last 2 terms. Because if I factor out negative 1, that means this negative 1 will go to negative 4s, positive 4s times. Negative 1 going to negative 11, positive 11 times. Okay, got to have these 2 parentheses match first. So when these 2 parentheses match, right now there's a subtraction sign here, so that means I got 2 terms. And what's the same between the 2 terms is the 4s plus 11. So the 4s plus 11 becomes my greatest common factor. Because it's 2 terms represent 1 greatest common factor, I got to put them in the parentheses. Because earlier, this negative 15 was not in the parentheses because this is only 1 term coming out, so I don't have to put it. If I got 2 terms representing 1 greatest common factor, they got to be in the parentheses. So if I take away the 4s plus 11 from the first term, 5s squared is left. In the second term, negative 1 will be left. So that will be your answer. Okay. So when we factor, the final answer is always in multiplication. Okay. Everything is actually 1 term. So what we did is start out with 4 terms, factor out 1 time, leave with 2 terms, factor again, end up with 1 term. Okay, that's what factoring is designed to do. Let's try another one. I'm gonna group the first 2 and group the last 2. So from the first 2 terms, factor out the greatest common factor, p. So that leaves me with p minus w. Alright, so now the next parenthesis got to match as the first one. So between the last 2 terms, I can factor out a negative 7. Because that will make this p a positive p. Negative 7 going to negative 7p, positive p times. Negative 7 going to positive 7, negative 1 times with the w. So p minus w match up, they become my greatest common factor. So this is 2 terms representing 1 greatest common factor. Got to put them in the parentheses. And what's left is p minus 7. So if you don't put the p minus w in the parenthesis, it will look something like this. That will actually tell the reader that this problem is actually 2 terms, because the subtraction sign here is outside the parenthesis. Okay, that's not the way we look at it. Alright, we'll do a lot of factoring by grouping later on in chapter 3 of this course. Alright, the next one I want to review is trinomials, factoring trinomial. A lot of students say trinomial is simply 3 terms. It's a little bit more than that. Trinomial is the last 3 terms of a polynomial. Okay, and it always has a form of ax squared plus bx plus c, where a, b, and c are your coefficient and your constant. A true trinomial got to have exponent that says 2 power, 1 power, and 0 power. Okay, to be called a trinomial. Okay, so my example here, my exponent is 2 power, 1 power, and the 28 doesn't have an exponent because it's supposed to be x to the 0 power. X to the 0 power is always 1, so that's why we don't write that 1. So this is a trinomial, and there are many different ways to go about factoring trinomials. Okay, so I'm going to briefly describing the way I normally do it. So when I factor trinomial, the first thing I'm looking for is the greatest common factor between the 3 terms. If I do not have one, I will write 2 parentheses right away. Alright, so step number 2, find all the factors, makes your first term and your last term. So what makes x squared? 1x and 1x. What makes 28? What times what is 28? The first one most people think is 4 times 7. So you're writing these numbers. Now you are actually trying to do your FOIL method backwards, because your outer, okay, give you 7x. Your inner give you 4x. And we want to make sure my inner and outer combined will give me my middle term 11. Which it can, because 7 and 4 added together will be 11. So the last sign tells you how the inner and outer combined to get the middle term. You go by adding. When the last sign is a positive, that also tells you the signs in the parentheses will be plus plus or minus minus. So it depends on what the middle term is. If the middle term is a positive 11, both of these 7 and 4 got to be positive 11. Got to be positive. So we put positive in both, and that's your answer. Alright, so we basically are performing a FOIL method backwards. Figure out the first, figure out the last, and then trying to do our inner and outer combined, see if we can come up with the middle term. Alright, so what I'm expecting you to be able to do is see it and know the answer. Okay, basically just without doing too much work, just kind of do it in your head. Alright, this is another trinomial, 2, 1, 0 power, no greatest common factor. So we will do the same step. No greatest common factor, 2 parentheses. The next step, find all the factor makes the first term and the last term. So what times what is 12? It's going to be 3 and 4. I think about 3 and 4 first. And the last term, 2, the factor of 2 are 1 and 2. Alright, so before I was even thinking about inner and outer, I already know this is going to be incorrect. Because when I put the 2 here with that 4 together in the same parenthesis, it actually creates a greatest common factor of 2. But we already said there was no greatest common factor in this problem, so naturally I cannot put this 2 along with the 4 when I shouldn't have a greatest common factor. So that means I will naturally put a 2 with a 3 and 1 with a 4. Then I'm going to try my inner and outer. Okay, I hope that makes sense, because if you have no greatest common factor, you cannot put numbers in the same parenthesis where they will actually create one. So right now my outer is 3. my inner 2 times 4 is 8. So I'm going to make sure my inner and outer combined can give me my middle term 5. And yes, it can give me a 5 if I what? Subtract them. So when the last sign is a negative, that means my inner and outer got to be subtract to get my middle term. When the last sign is negative, that means my signs for the parenthesis is 1 positive and 1 negative. So who gets what depends on the middle term. If the middle term is since the middle term got to be a positive 5, I will give my positive sign to the bigger of the two, inner and outer, because I need more positive than negative to end up with a positive 5 when I subtract. Alright, so that tells me that the outer need to be a negative 3 by doing 3 times negative 1 to get a negative 3. Therefore, this sign got to be positive, and put my variable x back in there, and that will be my answer. Okay. Alright, let's do the spatial factorings. I'm going to focus on difference of square here. So earlier we multiplied. Objective number 9. Oh, I'm missing one objective. I'm just going to write it out here for you. Alright, factoring difference of squares. So we're basically going to do the multiplication thing backwards like we did earlier. Where was it? Alright, so we're going to look at this difference of square thing backwards. So that means I'm going to give you the right hand side here. Then you're going to tell me what the factors are. Alright, so how you recognize difference of square? The wording itself. Difference means subtraction. Squares means the two terms got to be perfectly squared. So for example, if I have a 25 x squared minus 9, what you see is a subtraction sign between two perfect square terms. So this is a difference of squares. So what is your A? What was your A before it was squared? What was 25x squared before it was squared? It got to be 5x. And you write your answer in this form, follow the formula. Plus, what was 9 before it was squared? Or what was your B before it was squared? It must be 3. So my answer would be 5x plus 3 times 5x minus 3. And that's it. So, to factor a different square, you just have to memorize the formula and recognize that is a different square problem. Alright, another example. 3 minus 27 x squared. Right now, this problem does not look like a difference of squares because the 3 and 27 is not squared. So, we always got to go back and think about the first factoring things we learned. Greatest common factor. If you have a greatest common factor, you got to factor that out first. So between the two terms, I can factor out a 3. So that leaves me with 1 minus 9x squared. And I have not factored completely because inside the parenthesis, this is a difference of square because 1 is always perfectly squared. So that means I can factor again. What was my 1 before it was squared? Must still be 1 plus what was my 9x squared before it was squared? Got to be 3x. So that would be 1 plus 3x, 1 minus 3x. Alright. Now I'm going to wrap it up the review. The first part of the review with solving what we so-called a quadratic equation. The word quadratic does not mean 4. Quadratic equation is referring to equations where the exponent is to the second power. ax squared plus bx plus c equal to 0. This is your the standard form of your quadratic equation. Alright, a lot of steps, but I'm going to kind of briefly mention it to you. The first thing, always identify how many terms you have. Here I got 4 terms. I know this is a quadratic equation because the highest exponent is 2. Alright, there's no parenthesis in all the terms, there's no like term to combine. So we need to move all the terms to the same side of the equal sign. Alright, since my leading term 2x squared is positive, that means I'm going to move that 5 over. So that gives me 2x squared minus 13x. I'm going to go and combine it. I'm going to move it and combine it in my head. 5 come over, become negative, so that gives me positive 6 equal to 0. Alright, combine like term if I needed to. Since I don't have any like term here, I'm just going to factor this. Solving quadratic equation by factoring. This left side is a trinomial with no greatest common factor, so I will start off with 2 parentheses. The right hand side got to always equal to 0, okay? Find the factors of 2x squared, so that got to be 2x and x. The factor of the last term is 6, so that will be 2 times 6 that you think of first. Cannot put a 2 right here with that 2, because that will give you greatest common factor. So naturally you will put the 2 back here, put the 3 here, and do our inner and outer. My outer is 4, my inner is 3. 4 and 3 combined cannot give me 13 in the middle. If it cannot give me a 13 in the middle, my first instinct is to swap the position of the 2 numbers, which you can see does not work because the 2 and the 2 will be together again. That will give you the greatest common factor. So that tells you that 2 times 3 cannot work. So other factor that makes 6 will be 1 times 6. Put the 1 here, put the 6 here, because 6 can't go with the 2x. So now my outer will be 12. My inner will be 1. And 12 and 1 combined will give me 13 in the middle if I will add them. Since the last sign is a positive, that also tells me the signs for the 2 parentheses will be the same. Plus, plus, or minus, minus. So since my middle term is a negative 13, both my inner and outer got to be negatives. So when I add them, that will be negative 13. Okay. So once I factor, the next step will be set each factor equal to 0. So we are breaking down a quadratic equation, an x squared, down to a linear level, so we can solve it like a linear equation. Move my negative 1 over. That will give me 2x equal to 1. So divide both sides by 2. My answer x equal to 1/2. Alright, move my negative 6 over. My answer x equal to 6. Okay. Alright, let me do the next one for you as well. Alright, same thing. Quadratic, because the x squared right here. All my terms got to be on the same side, okay? And there's no distribution multiplying going on. So since my leading term is positive here on the left side, I'm going to move everybody to the left. So that will give me 5x squared minus 43x minus 18 equal to 0. Alright, let's factor. This is a trinomial here, so no greatest common factor between those 3 terms. So I will use, so the factor, the first term, 5x and x, 5 and 1. What times what is 18? I'm thinking about 9 times 2. Because I know if I put my 9 right here, see, I'm already doing my in and outer as I'm thinking about the factor. Put 9 right here, your outer will make it 45. 2 here, the inner will be 2x. So that will be 45. Inner is 2. And 45 and 2 combined will give me a 43 if I will subtract. Alright. Since the last sign is negative, the choices for the sign is one positive and one negative. So who gets what? Depends on the middle term. Since the middle term is negative, that means my negative sign got to go to the bigger of the two inner and outer. So that means the 45 got to be negative. The 2 got to be positive. Because now I have more negative than positive. So when I subtract them, I will end up with a negative 43. So the outer got to be negative 45 by having 5x times negative 9. The other sign is positive. So once I factored, set each factor equal to 0. And solve for x. So my answer, I'll move the positive 2 over, so that x will equal to negative 2 over 5. The other x will be positive 9. Okay. Alright, that's how we solve quadratic equation by factoring. Now the next problem is actually doing everything we just did backwards. Writing the polynomial equation with an integer coefficient. So basically I'm giving you the answers at the very bottom. We need to work our way back to the top, having the original polynomial. So the way you do it is actually do everything backwards by moving your answer back to the left side. Alright, so that will give you x plus 7 equal to 0 and x plus 3 equal to 0. Okay, so think about the previous problem. Where were the 5x plus 2 at before I said equal to 0? They were inside the parenthesis in the factor form. So I will do the same thing here. I will actually put my x plus 7 and the x plus 3 back into the factored form and set it equal to 0. So now I just multiply this thing out and I will have my polynomial. This is a FOIL method, so x times x is x squared. The last thing I do is positive 7 times positive 3, positive 21. Outer is 3x, inner is 7x. That will give me 10x. So this must be the polynomial, original polynomial right here. Okay. So the purpose of this review is to get everybody used to the way I do in algebra. You should already seen all these type of material already, and you should know most of these. Okay. I just want you to get familiar with the way I'm doing it. Now, if you find these material I reviewed difficult, please contact me. Okay. Let me know what things you are struggling with. Okay. And the way I'm doing these problems, I will do them the same way as we go along the semester. Alright, and I thank you for watching. The next video will be reviewing intermediate algebra material.